The West WU building was designed by the architect Kurt Halowinska and constructed between 1976 and 1982. In our analysis, we chose to focus on the building's envelope, the curtain wall, an architectural element that became a symbol of office buildings in the second half of the 20th century. Beyond being an engineering solution that allows light and transparent facades, it also carries a strong visual and cultural meaning closely linked to late modernist architecture. This kind of facade is not only a technical solution, but also the main visual element that defines the identity of the building. It wraps all facades and sets the architectural character. The facade itself is made of reflective double glass panels within an aluminum frame, assembled on the site in a modular way. While this method is efficient, it also brings significant challenges. From a climate perspective, in summer, the facade creates a greenhouse effect with uncontrolled heat and sunlight, while in winter it provides poor insulation, leading to major heat loss. Ventilation is very limited since only a few windows can be opened. As a result, the building depends heavily on mechanical air conditioning systems, which increases energy consumption and reduces efficiency. In addition, the curtain wall serves only a single program, making it very difficult to adapt the building to new functions in the future. Traditional European architecture often uses passive design strategies, such as thermal mass and insulation materials, to create comfortable indoor climates without relying solely on mechanical systems. Based on these ideas, we suggest adding internal atriums to the building. The atriums would bring in more natural daylight, and the retraceable roofs would help improve air circulation. In the summer, the roofs could be open to release hot air, and in the winter they could be closed to keep the heat inside. In addition, to improve insulation during winter, we propose adding thermal mass alongside the facade. Since effective thermal mass requires a thick wall, we suggest expanding this material so it becomes an architectural element in itself, large enough to contain habitable spaces. In this way, the thermal mass is not only a wall, but also an inhabitable layer of rooms that provide insulation and redefines the building's character. The thermal mass captures solar radiation during the day and stores heat. At night, it gradually releases the heat, stabilizing indoor temperatures and reducing energy use. By opening windows in the curtain wall, natural air circulation is enabled. Cool air flows inside, while warm air rises and exits through the atriums. The production of the thermal masses is planned to take place in the underground floor, next to the railway line, which will allow easy transportation of equipment and raw materials. The masses will be 3D printed from hempcrete, a material known for its low CO2 consumption and high thermal insulation. Printing is done in layers, with partial infill, so the trapped air pockets inside provide an additional layer of insulation. The mass is composed of fragments that can be assembled on the different floors of the building as needed. The reorganization of the interior spaces create a clear separation between private and shared areas. The shared spaces are designed for collective activities, such as cooking, sitting, and social interactions, while the private spaces offer a quiet space for sleeping and solitude. The new program allows temporary living from a single night up to several weeks or months. It is designed for a wide range of users, individuals such as students, travelers, or workers from European countries staying in Vienna for short periods, as well as couples and small families with up to 2 children. Since there are many curtain wall buildings around the world, and since they are designed for a single program, the question arises, what should we do with them when one day they're no longer suitable? Knock them down, leave them abandoned, or try something different? In our project, we propose to insert another layer of insulation behind the envelope. By creating inhabitable spaces within the massive wall, we suggest that it could become more than just a layer of the building. It could be an active living space that transforms and redefines the architectural experience. This approach demonstrates a strategy that can be applied to any building in need of adaptation.